Hi, my name's Niel Kirby. I'm a member of technical staff with Bell Laboratories, the research arm of Alcatel-Lucent, formerly Lucent Technologies, before that AT&T.
Can you give us a sense on what you've worked on with AI?
Most of my games are not out there and published. They've been sort of released. I worked on multiplayer tactical combat games in the 80s, back when networks only existed in large corporations and they were on Unix mini computers. And so we wanted something to do at lunch, and so I automated board games. And so when my office mate got pissed off when I ambushed him for the third time in one lunch hour, we decided to write AIs because he wouldn't be pissed off if the AI ambushed him, and we could run teams of humans versus the AI. So I wrote an AI using a Darwinistic approach. I simply wrote the simplest code that worked and did not cheat, and we then improved it. So every day for lunch there would be a slight change along the way. And I came out with what I believe are some first-time items for game AI. This segues to your next question, I believe.
Yeah, so actually what elements of computer science, math, psychology do you find yourself using?
Then let me retreat back to the other question about elements in the game. I believe I can lay claim to having invented circle strafe, believe it or not, and have the papers to prove it. My 1991 paper, Artificial Intelligence Without AI, an Evolutionary Approach, was in the proceedings for the 1991 Computer Game Developers Conference, way back when, in which the diagrams show a circle around the target at battle range and a circle around the moving object at his mobility, and when those circles intersect or overlapped, you basically wound up with circle strafe as a tactic. And my players got on my phone that day at lunch, and I was getting, "What did you do to the AI? We're getting killed down here! We're getting killed down here!" Once I unleashed circle strafe on them.
That's fabulous. So now, what elements of CS, math, psychology?
I have a master's degree in computer science and an undergraduate degree in electrical engineering with a heavy emphasis on digital systems. What I've found in my day job is that once a month, when I first hired in, something from my master's program would save me from making a mistake that would cost me hours to weeks of wasted effort. So my push to the students, particularly American students, first world students, is go to graduate school. They can't repossess your degree even if you go broke. It puts you higher on the value chain, so they can't outsource your work quite so easily. And it gives you the ability to do more and to call your own shots. And it also means you can do more in terms of your job. That if you want to do AI, you've got the background you need, the fundamental architecture. You've studied this. You've studied enough different parts of computer science that you're better at what you do. And it will free you. It gives you the chance to study, for example, artificial intelligence, amongst other things. Breadth is also important, which sounds odd when I just said go get a master's degree. And then take something in everything else. Cognitive psychology is not bad. A little bit of human factors is good. Documentation is actually good. Being able to communicate in English or whatever your language is also good. All that other stuff your university offers, if it's big enough to offer a master's degree, take as much of that as you can in a very broad sense. Your humanities will actually pay off. I used my Russian culture class in a game. Didn't expect to. I took Russian culture because I had to take something and it was a humanity, and so I took it. And 7 years later I'm using it in game code. Didn't expect it. You won't see those. So anything that's breadth. Learn to dance, okay? It's usable, okay? And creativity is also something you want to practice at. Athletes practice at athletics. Creative people like programmers should practice at creative things. Take up all the other problems of the world one at a time. Oh, chainsaw art on your firewood, okay? You'll burn all the bad ones in your fireplace. You've got metal stuff in your recycling bin. You get a torch and some solder and you can do sculpture, and then you recycle all the bad ones. But doing the creative thing is good for the brain, and it will help in your programming.
What would you want to tell academics who are teaching in game programs about the difference between game AI and academic AI? Where are we getting it wrong?
There's a couple of areas, one of which is that the perception in game industry about academia's attitude towards game AI is the same condescending shit every woman gets from men who don't know they're being condescending. So that's how academic AI, we're going to show these people what they're doing wrong, and I'm here to help, little boy. Okay. They have different worlds. The game has to ship by Christmas, and it must be at least this smart. And hard AI problems aren't on the bill. So it's practical, low level, get your hands dirty, make it a little bit smart. I mean, realize a thermostat satisfies the definition of an AI. It reacts intelligently to changing conditions. Okay, we can work up from there. Make it practical, and then give it to us. We want it. We want it all. Okay, we're starting to see things we couldn't afford, like we had to talk today on neural networks, which most games don't use. It's oversold in academia. It will occasionally get used in games, but all the other sort of neat, cool, frontline, researchy stuff is slowly getting practical. We need it practical. It's the difference between research and development. And for people, talk to people in the industry about the development side and getting stuff out of research into development, which is something I've done professionally.
Any advice you have for students looking to go into AI, or projects you'd like to see them tackle?
Couple of things. Game companies are for profit, and so they don't bill until they ship. Okay, so you're paying on somebody else's dime on spec until the game ships. Therefore, as a student, your biggest saleable skill is the ability to get one done. Okay, don't do 80%. Get one out the door. It has to be out the door before you can sell it. It shows your prospective employer that, yeah, this was cool, it was fun, and then it was a lot of work, it wasn't fun anymore, but I completed it anyways. I made it complete. So whatever your demos are, you'd like to have a nice portfolio showing what you do. Here, I do art. Show your art. Okay, it's complete. Here, I did AI. It's complete. Or here, I worked in a team, showing I can work in a team. Okay, I got all the personalities to work together, and we got it out the door. Okay, so do projects, make them something that you can get done, and get them done. Okay, that work ethic makes you more saleable than brilliance. Okay, ideas don't count. This industry is awash in great ideas they already have for free. They don't want yours. They want you to help them get somebody else's idea out the door.
And that is fantastic. Thank you very much, Dan.
You're welcome.